Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And before we get into today's podcast, again, we'd like to remind you that we're going to SVP, and if you'd like to help support us and pay for some of the trip, then please consider joining our Patreon. You can get highlights of our Australian dinosaur trip on Patreon and Discord, and we'll also be sending out postcards to all of our patrons with photos that we take during the trip. This week, in our 253rd episode, we have a bunch of news, including a quick review of Battle at Big Rock, which is the new Jurassic Park short that was released, Victoria the T-Rex, and an update on the Chicxulub study, meaning that impactor site where the dinosaurs were wiped out from. We also have an interview with Dave Hone about the new pterosaur discovery, Cryodraken, and of course we also talk about dinosaurs. And we have dinosaur of the day, Skorpiovenator. But before we get into all of that, we'd like to thank some of our patrons for helping us to produce this podcast for free on a weekly basis. And this week, we'd like to thank Chris, Nicholas, Trent Carbajal, Stefan, Nutmeg, Taya, Stego Sophie, Ayumi, Paul Acanthus, Lydia, Jackson Crawford, Sorian Brandy, Mayu, Dino Bo, Mellow Stego, Wiki, and Rachel. And Rachel just joined, so thank you so much for joining.
Yeah, thank you to everybody. As Garrett said, this helps us produce our podcast every week for your enjoyment and our enjoyment too. And we hope to keep this going for as long as possible. So if you want to help us out, then check out our page at patreon.com/iknowdino.
Jumping right into the news, thanks to Chris for tweeting this first article to us. We have, like I said, a follow-up from the research at the crater that wiped out the dinosaurs. And as a quick reminder, because it's been a little while since we talked about this, we interviewed Sean Gulick about this way back in episode 105. He was the lead on the first paper about this. He's also the lead on this current paper, along with a whole bunch of other authors. There are 30 co-authors. I think maybe 30 is the limit for the Proceedings of the National Academies of Sciences, because number 30 is just the Expedition 364 Scientists, which is the name of the group that did the drilling. So, yeah, it's like
pretty cool.
There were a ton of people involved in this, and it was an insane amount of work. But as a reminder, they went just off the coast of the Yucatan Peninsula in Mexico, and that's the site where the impactor hit, which caused all sorts of devastation all over the world, wiping out all of the non-avian dinosaurs. And at that spot, they set up a little miniature oil platform because I think they were about 30 to 60 kilometers off the shore of the Yucatan Peninsula, and there was a fair amount of water. I think it was somewhere around 30 to 100 feet of water that they had to drill through. So little mini oil platforms are designed for exactly that purpose. And there's actually an organization that does these scientific drills all over the world. It's pretty cool. So they managed to snag it for a couple months to do this experiment. And what they did was they drilled down into the peak ring of the Chicxulub crater. And the peak ring is something that you only see in really big impacts. Basically, it's a ripple that's caused by the molten rock after the impact. It kind of settles out. It's not the rim of the crater, it's inside the rim of the crater, but it's this other bump that's in the crater itself. It's a very unique thing, so it's definitely worth studying just from a geological standpoint. But then you get the bonus of figuring out exactly what the days immediately following the impactor was like by looking at how the rock and sediment and things settled down in that spot where the impactor hit. So in order to do this, they drilled tons of cores because you can only take out segments that are short enough that you can still ship them and maneuver them. So I think they were just a couple meters long each, and they had to go almost a mile down. So you can imagine how many of those individual cores they had to take. And they also had to go slowly and carefully because they wanted to preserve as much of the detail of these cores as possible. They didn't want to break them, and they wanted to have a nice clean core each time. So we talked before about what they found among the cores and kind of what kind of rock was in the cores. But what this paper focused on was the sediment that was deposited right above the crater. So in other words, right after 66 million years ago, what all settled in on top of the crater, and therefore what was going on in the immediate moments after the crater and after the impact itself. Fortunately, after they took out all of these cores and started studying it, they've been storing the cores in a huge refrigerator just to make sure if there is anything living in there or anything else significant that might decay if it was exposed to just the regular atmosphere and temperature, that this might slow it down a little bit. So it's really quite the endeavor that they managed to achieve here. This specific paper is titled The First Day of the Cenozoic, which I think is great. The Cenozoic obviously is the period immediately after the Mesozoic, when all the dinosaurs were around, the non-avian dinosaurs. So we can actually see in the sediment that now this is the first day of the Cenozoic. By definition, it's the only place in the world that we could be 100% certain that that is the first day of the Cenozoic.
It's a dark day.
It was, both literally and metaphorically. So what they did in this paper is they looked at about 130 meters of rock that is immediately above the crater itself, the melt rock that was formed by the crater. Specifically, they can break it down into a few time periods after the impactor hit. The first period was about 10 minutes long, and it's about 40 meters or 130 feet thick, which means in those 10 minutes, 130 feet of rock piled back on top of this crater. It's mostly large rock chunks, some of which were formed when melted rock solidified from water resurging back into the crater, because again, what happened was the asteroid hit and it blasted all of this water and vaporized and everything else, the water away from the crater. So it's completely barren momentarily. And then after the ground fell back down, basically, the water rushed back in. So briefly, this part of the Gulf of Mexico was 100% dry. Or maybe, I don't know how you define dry. If you define dry as a lack of water, then yes, but dry as a lack of liquid, no, because there was molten rock. But in any event, the water rushed back in, it solidified some of the rock, and then other rock chunks just fell down that had been thrown all over the place. Carnage, 130 feet of rock in 10 minutes. It's crazy. Then the period of the next few hours is a 90 meter or 300 foot thick chunk of rock. And that's all from seiches. And seiches are what happens when you have a massive earthquake and there's water underneath it. It's like a tsunami, except that it kind of sloshes back and forth a little bit more. And so this is just water that was rushing up onto the US, onto Central America, and onto South America, basically ripping all of the topsoil and everything else off, flushing it into the Gulf of Mexico. So it filled 300 feet of rock from these seiches, also from debris that had been blasted all over the Gulf of Mexico, would have had to resettle back into that crater, because if everything's getting sloshed all over the place and the crater is that low point, it's going to obviously fill that up. In that spot, too, we can see that the sediment gets finer as you go up in the 300 feet. So you can tell that there was still quite a bit of movement. It wasn't just a gradual deposit, because if it's a gradual deposit, you don't see this sort of settling like we can see for 300 feet of rock. It's an insane amount of material to be kind of moving simultaneously, but that's what was happening. Then within 24 hours of the impactor, there's a thinner layer of gravel and charcoal, and they think that's from the tsunami returning to the crater from other continents and also from bouncing off of the far side of the Gulf of Mexico. So this is the tsunami itself from far away. It's not really a seiche, because a seiche has to be in a confined sort of area, but in order to get stuff back from all over the world, that's going to be the tsunami itself going out and then returning. And actually, as we saw in models, did that many, many times for days, bouncing all over the earth, causing these huge 10-foot, 40-foot waves everywhere, just decimating everything. And we also know from other research that before that 24-hour period was up, a lot of the earth was on fire. And that's from all the energy released from the crater and then the raining glass when it condenses, releasing heat all over the place, and then causing massive forest fires everywhere. So some of what was returned in that 24-hour period with these returning tsunamis was charcoal from all the burning forests. Then there's a layer which was deposited from weeks to years, And if I'm reading it right, it's only 75 centimeters or 2.5 feet of limestone, which relatively sounds like nothing because we're talking about hundreds of feet. And then all of a sudden, years, it's only like a foot or two.
But if it's weeks.
Yeah, that's true. It's potentially shorter. And this is where the first sign of life appears. We see just chemical markers that it appears that there's life back in the mix. The two biggest takeaways from the new article are that there was that charcoal mixed in with the debris, and it 100% confirms the fact that we had these widespread fires, because you're just not going to get a big layer of charcoal in the middle of the ocean unless there's a bunch of fire around and that fire and burnt wood is getting brought back to the crater. It just doesn't make any sense if you're in the middle of the water to find charcoal. But in the case of fire everywhere, it does make sense. So it's really the first 100% guaranteed evidence that we have that there were fires far from this crater because there wasn't any wood at all right by the crater.
That's pretty crazy.
Yeah. The other interesting takeaway from the article is that there's a decided lack of sulfur in the rock itself, which means that it must have been somewhere else, and the most likely place is up in the atmosphere as a gas leading to global cooling. And from earlier paper estimates, they think it was about 100 gigatons of sulfur that was released, leading to about a 20 degrees Celsius cooling that could have lasted for up to 30 years. So this is that nuclear winter scenario where the whole Earth is basically shielded from the sun and temperatures plummet to basically freezing. And obviously that leads to crazy mass extinctions, like wiping out all non-avian dinosaurs, for example.
Yep. That'll do it.
Yeah. They also acknowledged the paper about the soot in the upper atmosphere causing cooling. We mentioned before that there were kind of these two different papers. There was one talking about sulfur in the upper atmosphere reflecting light and therefore cooling the Earth, and another talking about really fine particulate soot in the upper atmosphere, which would have also cooled the Earth. But in this paper, they didn't assign a temperature reduction to the soot. But if we think that both were going on at the same time now, because it seems like there's pretty good evidence for the sulfur being released, I don't know how much that temperature would have dropped. 20 degrees Celsius, like I said, is near freezing basically everywhere on Earth. So I don't think it really matters that much because if it's winter everywhere, things that aren't designed to handle winter are going to die off after a couple seasons anyway. So no matter what, you're going to have massive extinctions everywhere. But it would be nice to know how much soot was up there as well. Something I think we can't really tell from this specific research, though.
We always knew it was bad, but now we know. Now we have an idea of how bad.
And some really hard evidence of exactly what happened. I'm glad we weren't around then. But I am glad it happened, because otherwise we probably wouldn't exist.
Oh yeah, the dinosaurs would probably still be thriving. The non-avian ones, I should say.
We'd be stuck in our little burrows like our ancestors.
Well, speaking of non-avian dinosaurs from the end times, we've got the second most complete T-Rex skeleton, at least known so far, that's going on a world tour for the next 5 years. And this T-Rex is known as Victoria. And Victoria was between 18 and 25 years old when the dinosaur died. The fossils were found in South Dakota back in 2013, and it took 8 months to excavate 199 bones.
Yeah, that's a good find.
Yeah, very complete. And then it was brought to a lab in Victoria in British Columbia where it was studied and prepped, and that's how it got the nickname. So Victoria was about 40 feet long and 12 feet tall and probably weighed 10.5 tons. And they have a complete skull. There's an absorbed tooth in the jaw.
Interesting.
And 2 teeth that grew out of the same socket. There's also teeth that may have been broken from crushing bones. Victoria has some fused vertebrae that shows severe neck trauma. There's a bad infection in the mouth, too, after being bitten by another T-Rex, which is probably what killed Victoria. There's a lot of papers that will be coming out about this T-Rex in the future, but in the meantime, Victoria starts the world tour at the Arizona Science Center in Phoenix and will be there from November 17th to May 25th of next year, and then move on to other countries. And anyone who visits can see the complete skeleton, create a hologram of Victoria, interact and learn how this T-Rex lived, and watch scenes of Victoria portrayed as a mother, a hunter, and a protector. And you can buy tickets online now. You do need to go at specific times.
Cool. That lines up with the Gem and Mineral Show, although it sounds like it's in Phoenix, so it's a little ways away since the Gem show's in Tucson.
Yes. But if you're looking for things to do in Arizona.
Yeah. I don't think you can find any other really amazing T-Rex to look at anywhere in Arizona.
Or you might, and we're just not aware. If you're not in Arizona, if you're in somewhere like, say, Indianapolis in Indiana, the Children's Museum has a new Jurassic Paleo Prep Lab where visitors can watch scientists prepare the fossils found in Mission Jurassic, which we talked about Mission Jurassic before. That's where scientists from around the world are excavating in the Morrison Formation. And you can also touch specimens and ask questions.
Where else could you go?
Online, I guess. The next thing is about dinosaur media. There's a new children's show called Super Dinosaur that's going to be on Amazon on October 6th. There's 13 half-hour episodes. And it's about a 10-year-old genius named Derek Dynamo and his best friend, a T-Rex named Super Dinosaur, and they have to protect their planet against evil.
Oh, that sounds fun.
And then in Jurassic World news, first there's a quick update. The Jurassic World Evolution game has a new herbivore dinosaur pack. Costs $5, and you get 3 new dinosaurs: Dryosaurus, Homalocephale, and Nigersaurus.
Nigersaurus is so cool. I'd be tempted to buy that if I was still playing that game.
Yes, if you want to learn more about Nigersaurus too, we go into it in depth in episode 246. And now the bigger Jurassic World update. Many of you probably saw the 8-minute short film Battle at Big Rock, which is set 1 year after Jurassic World Fallen Kingdom. It's directed by Colin Trevorrow. If you haven't seen it yet, spoilers, it's very short. You can watch it online for free, so no excuses. But if you haven't seen it yet, you might want to go watch it and then come back to this.
Yeah, there was quite a bit of discussion on our Discord server about this and what was potentially inaccurate about it, because it's not, I mean, it's Jurassic Park, so you don't expect it to be the most accurate thing ever. But
Sure, but I do like the concept.
I did too. Yeah, I thought it was a pretty fun scene.
So basically the story is there's this family camping at Big Rock National Park, about 20 miles away from the mansion where the dinosaurs escaped from.
Oh, really?
Jurassic
That's where it's
World
supposed to be.
Yeah. And according to Colin Trevorrow, it's, quote, the first major confrontation between dinosaurs and humans. And Trevorrow co-wrote this with Emily Carmichael, who's also co-writing Jurassic World 3 with Emily. And he said, quote, it felt like a first step into a larger world after the last film. You have these animals loose in an unfamiliar environment. They're disoriented, struggling to adapt. The first people they run into are bound to be camping. I wanted to see that.
It's really interesting because there's a little girl in it and she immediately recognizes the ceratopsian, and it's not Triceratops, but she's just like, oh, it's a Pseudoceratops or something.
Mm-hmm.
And you're like, okay, well, if these are, I had assumed that they were all over the place, so she was familiar with what kind of ceratopsians were out and about. I'm willing to bet that if this was the first time a human saw it, they'd be like, that's a Triceratops.
I don't think it's the first time they saw the dinosaurs. It's just the first confrontation.
But we're 20 miles from the place where they were released. So wouldn't it be like they were camping and they got released like a couple hours before?
They got released a year before.
Oh, it's a year before? But
Yeah.
This is the first confrontation.
So that's what Colin Trevorrow said, although I thought I remembered hearing the family talking about, oh, do you remember at school they talked about these other incidents? And maybe these are smaller incidents. Because it does say major confrontation.
Interesting. Yeah, it's kind of weird.
Yeah, so it's 1 year after Jurassic World. There's an Allosaurus, it was a juvenile in Jurassic World Fallen Kingdom. Now it's grown because it's been a year.
They don't grow that fast. Come on. But it also looked really weird. The Allosaurus, when I saw it, I thought it was supposed to be a T-Rex, but then you notice it's got those bumps by its eyes, and you're like, oh, is that supposed to be an Allosaurus? But it's got that super wide Tyrannosaur-like jaw.
Mm-hmm.
So it's just like all Jurassic Park things. It's got like a Tyrannosaurus sort of ratio of skull to make it look tougher. But I wish they would have made it like an Allosaurus head, with a nice narrow and not big T-Rex teeth sort of head. And it would have been smaller and quicker, which would have actually worked better with the scene.
Right. And so the scene is there's this family camping and they're about to sit down to dinner, and then they notice that the campgrounds have gone completely quiet. And then they see the Nasutoceratops, and it's totally fine in the beginning. It kind of feels like we're watching them watch a show
Mm-hmm.
because they're seeing it through the glass of their RV. And the Nasutoceratops is just kind of looking for food, sees the fire, and then a baby pops up, and everybody's admiring the cute baby.
Yeah. Oh, baby.
Mm-hmm.
But you know what else likes babies?
Carnivores.
Yeah.
Right, so then they attract the Allosaurus, and that's where the fight begins. At one point, another adult Nasutoceratops comes in too, so then you've got the whole family fighting.
And so you kind of figure it's over because you got the two ganging up on the one. So you figure, oh, okay, they'll be safe. And that's what the people in the RV are saying too. Like, oh, it can't take on both of them. So it'll have to scamper off.
Right, but then the Nasutoceratops family leaves, and something attracts the attention of the Allosaurus to the human family's RV.
Yep. Kind of hearkening back to some of the scenes in the other Jurassic Parks where a kid makes a noise when they shouldn't.
Yes. Oh, that's what it was. There's a baby that cries.
Yeah.
And then you've got the crazy scene of the Allosaurus attacking the RV.
Yeah, and RVs are notoriously flimsy, so it just tears through that like nothing.
Mm-hmm. Which they did a really great job capturing the terror of that scene.
Yeah, I thought I enjoyed it as much as a lot of the scenes in the most recent Jurassic World movie.
I did like how it ended with the girl, I don't know exactly how old she is, maybe 8 or something.
Yeah, that ballpark.
Yeah, she ends up saving the day with a crossbow. It's pretty epic.
Which I was saying in the Discord server too, is a little weird because a lot of these dinosaurs are like bulletproof. They were shooting them and the bullets just kind of bounce off. But arrows are like their kryptonite, apparently. You just shoot it with an arrow and it's a goner, but you could shoot it with a whole clip full of ammo.
Maybe if you get
totally
it in the
fine.
exact right spot.
I guess. I don't know.
Could be. But I really like this idea of the girl saving the day.
Yeah. Yeah, it's kind of funny too because they were yelling at the neighbor like, "Don't teach my daughter how to use a crossbow," and then she saves the day with a crossbow.
Yeah. And then the end of the film, there's clips of other humans interacting with dinosaurs and other animals. They've got Compsognathus, Stegosaurus, Parasaurolophus, and then the Mosasaurus and Pteranodon.
Yeah, I really like the Stegosaurus one the best because it's basically somebody driving down a road and then they come out of a tunnel and there's a Stegosaurus right there, so they have to swerve to avoid it. And I was just thinking, yeah,
that would happen.
That would definitely happen. The largest thing anybody hits on a road nowadays is a moose, which is probably a quarter the size of a Stegosaurus at most. And that'd be a nightmare.
I'm surprised there wasn't any mention of people hunting dinosaurs. Maybe that comes later in the movie.
Yeah, that's true. You would think that with these big herbivorous dinosaurs, they'd be pretty good eating. And if they'd been loose for a year, well, I guess dinosaurs don't breed that quickly, so you wouldn't have to cull them quite like deer, maybe, or kangaroos. But you could imagine some of the smaller ones, like Compsognathus or something. There'd be serious epidemics of them, like a blight of Compsognathus running across the city, like a huge horde of coyotes eating everybody's pets or something. Then there'd have to be big efforts to try to combat them. I hope that's where this next movie is going. It seems like it is because it's sort of showing that transition now, which I think is the most exciting thing you could do with a Jurassic Park movie. It was my favorite part by far of the second Jurassic Park, Lost World, where you had the T-Rex in San Diego and just imagining how like people deal with this dinosaur getting thrown into their world in a pretty realistic way. Nobody's really fully explored before.
Mm-hmm. Yeah, I'm excited to see where this movie goes.
Yeah.
So apparently for this short film, they shot it over 5 days in Ireland last winter. I wonder if it'll be like Game of Thrones where they have multiple places around the world they film.
Oh, yeah, that'd be cool to not just see it in the, California forest sort of environment, but to also see maybe what they're doing in like cold environments and hot environments and which dinosaurs they show as like suited to those places.
Right. Maybe some bigger cities, like they alluded to Las Vegas at the end of the last movie.
Yeah. Yeah, that'd be cool. So what is it? We got about another year or two, then we'll find out.
June 2021.
A little less than 2 years.
Mm-hmm. And like I said before, if you haven't seen the short film yet or you want to watch it again, you can watch it online and we'll post the link to YouTube. And now on to our interview with Dr. David Hone. And for our patrons, we have an extended version of this interview as some premium content.
As usual. We're joined this week by Dr. David Hone, and he is a lecturer in zoology at Queen Mary University of London. With this interview, I think he's our most interviewed guest. He's an expert in both dinosaurs and pterosaurs, and you might recognize his name from the Tyrannosaur Chronicles, and he also has a blog called Archosaur Musings, but he's here today because he recently described a new pterosaur. But of course, this is a dinosaur podcast, so we have some dinosaur questions too. Thank you so much for joining us.
That's okay. Nice to be back.
So, since you have this new pterosaur, it's an Asdarkid, right? Is that how you say it?
Yep. Some people emphasize the "j" a bit, so more Asdarkid, but it's fine. No one's counting.
So, could you tell us a little bit about what an Asdarkid is, or Asdarkid is?
Yeah. So these are pterosaurs that are mostly hanging around towards the end of the Mesozoic. They're particularly common once you get into the Late Cretaceous, and indeed they're one of the few pterosaurs which are around in any numbers in the Late Cretaceous. Until fairly recently, we thought they were pretty much the only thing once you get into the kind of Campanian Maastrichtian in the last 10 million years. And in general, they're very big. So Quetzalcoatlus is the one everyone's heard of, with the 10 plus meter wingspan, 250 plus kilos. But they have relatively big heads, even for pterosaurs. They have relatively long necks, even for pterosaurs. But then they also have pretty long legs, and their wing proportions are a bit weird. And basically, we interpret these as being fairly terrestrial animals. That doesn't mean they weren't capable of flight. It doesn't mean they weren't actually very good in the air. But their predominant lifestyle, we think, would have been terrestrial. And so you're thinking of things like some of the big storks and herons and secretary birds and big hornbills and stuff like that.
So are they kind of lanky?
Yeah, basically. I mean, there's this almost trope at this point of comparing the big ones to giraffes, which I think Mark Witt started. And the thing is, if you stretch the face of a giraffe out into a big pointy beak, the proportions are about right. It's a really big head with a really big neck and a little body and really long legs. So yeah, it's pretty much a giraffe with wings.
And they were sort of quadrupedal because they their wings sort of folded so they could stand on their hands in the middle of their wings.
Yeah, so that's kind of where their proportions are weird. So obviously pterosaurs are flying off this greatly elongated fourth finger and off an elongate hand and arm. But most pterosaurs, most of the wing length, if they stretch the arm out, is wing finger. And in Asdarkids, it's actually only about half the length. So obviously it's still a greatly elongate finger. But when you look at something like Pteranodon, where maybe 3/4 plus of the wing is finger, this is really quite a short distal wing, and a huge amount of the wing is actually made up by the hand.
Oh, okay.
That's where their proportions are a bit weird. And then that's because they've got such long legs. They're well adapted to walking because they've now got great big long legs. And then the arms, or at least the front part of the arms, are elongate to be commensurate with that. And so that's how they're getting around.
Interesting. So with a smaller pterosaur, with that really long finger part of the wing, does that mean when they're on the ground, their wing would really be sticking up higher than their head, maybe even?
Yeah, probably. I mean, it depends on the posture, particularly the early pterosaurs. There's a big debate about whether they were kind of almost lizard-like sprawlers or relatively upright. Certainly everyone's happy that the derived pterosaurs were much more upright. But yeah, if you shift those proportions and you have a relatively short proximal bit of the arm, so the upper arm bone, the humerus, the radius ulnar, and then the wrist, then you're obviously going to have a much longer lower part of the arm, which is going to be sticking up once you folded your wing down.
That's weird.
Mm-hmm.
Yeah, as Asdarkids, I mean, pterosaurs are weird. Pterosaurs are really weird. And yet, even among pterosaurs, the Asdarkids are pretty weird.
It's kind of like a double negative to me, though, because it's like the early pterosaurs are weird, and then this is a weird pterosaur, so it makes it almost seem more normal again. Like it's using its arm for flying rather than just a finger.
Yeah, I don't know what to add to that. Pterosaurs are weird.
So, since I don't know that much about pterosaurs, and I feel almost like a lot of people are with dinosaurs, where like they see Jurassic Park and that's mostly what they know about dinosaurs. I feel the same way about pterosaurs. So have you seen Jurassic Park 3?
I have, yes, well, all of them. So I made the case on my blog once that I think Jurassic Park 3 is the best one of the series.
Wow. Minority opinion.
Yeah, well, I mean, it was somewhat facetious, but the central point I think is entirely justified, which is of all the films, and that includes both of the new Jurassic World ones, it has the highest amount of screen time of dinosaurs and the lowest amount of screen time of children. And so since I go to see Jurassic Park films to see dinosaurs and not annoying kids, then the film which has the most dinosaurs and the least kids would appear to be prima facie the best film.
It's a good thing they didn't make the first Jurassic Park like the actual book, because in the book, the kids were just like horrible and they kind of toned them down for the movie.
Yeah. Yeah. But yeah, Jurassic Park 3, I mean, the pteranodons in that aren't bad, other than the bizarre decision to give them teeth. When pteranodon means tooth swing. So it's that classic thing of we did extra work to make things less accurate. So could have done less work to make them better. But yeah, the pterosaurs in Jurassic Park 3 are pretty good. The pterosaurs in Jurassic World were appalling.
Why is that?
All the details are just out. Yeah, I mean, the dimorphodons in particular, I mean, the wing shape is all wrong. The head shape is all wrong. Dimorphodon, again, means two types of teeth. They all have the same type of teeth in the jaw. They've got these giant, grippy, talony feet with which they're picking people up. There's no way that Pteranodon would be able to pick people up. And okay, yeah, they did that in Jurassic Park 3, but then also they did it once and the animal really struggled to get in the air, whereas they were quite happily flying around with people in Jurassic World. And yeah, it was just generally all a bit horrible.
And I think in Jurassic Park 3, too, it was a child versus like tons of adults in Jurassic World.
Yeah.
Does that mean you don't think either of them could have lifted much weight?
I don't. I looked into this once because someone on a website I used to run called Ask a Biologist, someone once asked with the Twitter down graphic, how many bluebirds would it actually take to lift up a whale? And I did a little digging into the literature on the lifting capacities of various birds. And it turns out that relatively small birds can actually lift up like 2 or 3 times their weight. They don't do very well with it, but they can get into the air and fly with it. So one that people may have seen is peregrine falcons will kill pigeons much bigger than themselves and then fly off with them.
Oh, wow.
But once you start getting bigger and bigger, you get closer and closer to the limits of flight because of the way various proportions tend to work. And so small things can lift stuff much bigger than them, but big things can't. And therefore, actually, how much these guys could have got away with it, it's very hard to say.
Cool. So we should talk about your new pterosaur discovery. Could you tell us a little bit about that?
Yeah, sure. I mean, the first thing to say is I didn't find it. Several people already congratulated me on my amazing find. It's like, well, people dug it up in the 90s. So it sure as hell wasn't me. So Dinosaur Provincial Park, so kind of southern Alberta, northeast of Calgary, very famous place, huge numbers of fossils, World Heritage Site, constant excavations. For a long time, they've been pulling out bits of Ashdarchid pterosaurs. The earliest one we could find in the collections dates from the mid-60s, and there's a fairly well-known partial skeleton from 1992, which has been described in some detail, actually, back in the early 2000s. And people have always kind of assumed isn't perhaps quite the right word. They've always considered it to be Quetzalcoatlus, so the big famous Texan one. And then Mike Habib, who I've done a lot of papers with, is a colleague of mine, done quite a lot of stuff on pterosaurs and other things. He was lucky enough to see a lot of the Quetzalcoatlus material. And then he was also looking at the specimen, particularly the skeleton in the Tyrrell. And he came to me, and because he's not really a taxonomist, and said, well, I've got a sneaking suspicion this isn't Quetzalcoatlus, and I want to work on this thing, but obviously I don't want to describe or discuss something that isn't what I say it is. Do you want to have a look at this for me / with me? And I was like, yeah, sure. So I looked at the stuff that he had on Quetzalcoatlus. I compared it to all the other Ashdarchids that we know of, and it was fairly apparent that this thing was not the same as the others. And obviously, if it's demonstrably different, then it's a different taxon, and therefore it gets its own name. So this paper that we had out this week is us basically putting a name on the specimen, or this group of specimens, and we've called it Cryodracon boreas, which is basically the frozen dragon of the North Wind, which is...
It's a good name.
Thank you very much. I mean, we thought it was quite good, but people have responded extremely well and seem to think it's like the best pterosaur name ever. And it's like, if you want to think that, I'm happy to let you.
Quetzalcoatlus is also really hard to say and also hard to read by looking at it.
I always have to think every time I spell it as well.
Yeah. It's a cool, like the etymology of that one's cool too. It's just a little bit harder for English speakers, I think.
Yeah.
So since we don't know too much about pterosaurs, what are some of the differences between the two?
Yeah, so I've been asked this a lot already because there's been a bit of a media splash, and it's one of those typical things where you go, well, for us, this is really cool, but for the average person and even maybe the average dinosaur enthusiast, it looks really pathetic. One thing you've got to remember about pterosaurs is just how little skeletal material we generally have, and just how incredibly conservative they are. So we tend to name new pterosaur species and genera off fewer differences than you would a dinosaur, because there are just fewer differences there. But the main thing is the pneumatopores. So people may have heard of pneumatopores, pterosaurs, and indeed lots of pretty much all theropods and sauropods and indeed modern birds basically have openings into the bones to make them hollow, and these are extensions of the lungs basically feed into these. And the pneumatopores are the holes where the air sacs from the lungs go into bones. And the size, shape, and position of these is known to be pretty consistent within various pterosaurs, but different between them. And that's what's doing a lot of the diagnosis here for Cryodracon. So compared to Quetzalcoatlus, for example, there's lots of things going on here. So if you look at the neck vertebrae, which is what we have a huge amount of for the Azhdarchids, and they're really important with their great big long necks, basically there's usually 2 or 3 holes at the end of each vertebra. So there's 2, one on each side, and some have one at the top and some don't. Cryodracon has one at the top, which already makes it quite unusual because quite a few don't have that. And the 2 that it has at the side are really low in the vertebra. So there'll be an opening in the vertebra for the neural canal, for basically the nerve cord to connect the brain to the rest of the body. And in every other Azhdarchid, the 2 little pneumatopores basically sit above that, one either side, but at a higher level. In Cryodracon, they sit below it. And that's true of basically every specimen that we have. So we've actually got 7 or 8 different vertebrae from maybe 6 different animals. For Cryodracon, so very fragmentary. We've just got bits of vertebrae, but they all show this pattern of pneumatopore at the top, and the one each side are much lower down than you would normally expect. So that's basically the big thing, which is suggesting that this is different.
Right.
Is Cryodracon the biggest pterosaur? I've seen some articles claiming this, but I want to give you a chance.
We definitely didn't say that in the paper, and we definitely didn't say it in the press release, but that doesn't mean that people don't pick it up. The main specimen that I've been talking about, so the one from 1992, there's a neck vertebra, there's some chunks of a wing, some chunks of a leg, and a rib, and a couple of other bits, which in the grand scheme of things for Azhdarchids is actually a really pretty good specimen. And that's a juvenile of maybe 5-ish meters in wingspan. So, a very sizable animal, but again, Quetzalcoatlus 10.5 plus meters, not that big.
Right.
What we do have is one extremely fragmentary giant vertebra. It's really broken. It was originally misdiagnosed as a tyrannosaur limb bone.
Wow.
Which is just how big it is.
And how broken.
And it's basically a tube. So the Azhdarchid neck vertebrae are basically tubes with a bit of articulation on each end. And this is a tube with both the articulations missing. So it's really broken. But we've got very good vertebrae for Quetzalcoatlus. And if you compare this to Quetzalcoatlus, and indeed the bigger specimens of Quetzalcoatlus, it lines up really well. It's about the same length, it's about the same width, it's got the same rough proportions, and therefore it's not unreasonable, despite the fact that it's obviously extremely fragmentary, to suggest that it's about the same size. And in that case, you're looking at a 10-meter wingspan animal. And there's a bunch of these. There's Quetzalcoatlus, there's Aramborgiania, but it looks like Cryodracon should be part of that discussion. There's no way I'm going to say it's the biggest one ever based off literally half of one vertebra. But equally, there's no reason to think that it isn't producing animals of similar sizes. And the fact actually that we've got 3 or 4 different taxa, all of which are about this size, suggests that actually it's a fairly common thing.
So being this huge, being terrestrial mostly or semi-terrestrial, what was it doing? Was it eating dinosaurs or eating small mammals, or what does it do?
Yeah, so we think they're predatory based on the head shape. And yeah, I mean, just that they're going to eat whatever they can get down their throat. I mean, if you've seen big herons, big storks, everyone thinks of them as being fish eaters, and okay, they do a fair amount of that, but they'll quite happily run around and gobble up, rats, rabbits, small birds, anything like that, lizards that they can grab.
Just opportunistic.
Right, they're opportunistic predators, and we think they're doing something very similar. Yeah, they're just grabbing whatever comes their way that's small enough to go down the gullet. We don't have any direct evidence, so sadly we've got no ashdarchids with stomach contents.
Yet.
Yeah. Well, we've got like 2 skeletons which were even good enough to have had stomach contents, if you were lucky. Both from China from the early Cretaceous. But there's no direct evidence, but these are clearly predatory animals. They got a big mouth. There's nowhere else other way they can reasonably hunt.
Do we know anything that ate them?
Cryodracon, entertainingly, has been written up a couple of times, partly with the description of the skeleton, but originally the tibia, so the lower leg bone, has several bite traces on it from a small theropod dinosaur, and indeed a shed tooth embedded in the bone. This has always been inferred as a scavenging trace, and I think that's quite likely. So, I can't imagine a small dromaeosaur or troodontid pulling down a 5-meter ashdarchid very easily. It could have happened, but I doubt it. So there's one. And then a few years ago, God, probably 10 years ago now, actually, I described a specimen from Mongolia in a Japanese collection, which is a velociraptor with a pterosaur bone in it. And that was an ashdarchid bone, which, again, we inferred to be scavenging on the ground. That was quite a long one. It was quite impressive how it actually managed to swallow it. But presumably it was desperate, because if you've got a pterosaur on you, and particularly a ashdarchid, there should be some good muscle on the, there should be some nice meat on the flight muscles and stuff.
Right.
And if you're now swallowing limb bones, you've probably kind of exhausted, the available nutrients at that point.
Swallowing them whole.
Something bigger got to it first.
Yeah, so we know of at least 2 different incidences of small theropods feeding on them, which is not necessarily the same as killing them. But, the obvious thing is you've got tyrannosaurs out there, and I doubt they did it very often, but I bet it happened, because sooner or later one's going to be old or injured or just not paying attention. And yeah, there should be good eating on a big-sized ashdarchid.
Yeah. I wanted to ask too, I saw a lot of depictions because there's a lot of cool paleo art that came out with Cryodracon, and it shows it kind of fuzzy. Is your assumption, or your best guess, I guess, that Cryodracon had that sort of dino fuzz that we think a lot of pterosaurs had? Shouldn't call it dino fuzz.
Yeah, so they have a technical term, which is pycnofibers. And yeah, it's similar to the filaments that we see on baby birds today and some of the earliest feathered dinosaurs. So they're simple hair-like structures. A couple of people have suggested that these are true feathers, in the sense that they have a shared evolutionary history with feathers in dinosaurs. I'm pretty unconvinced by that. I'm certainly open to the possibility. That's been discussed for 25 years now, but the evidence for it isn't great. But what we do have is, across the kind of pterosaur tree, we have all kinds of different groups from different times, different places, different environments, doing different things, terrestrial ones, fishing ones, small ones, big ones, and they all have this. When the conditions are right to preserve it, they all have it. So that gives us, it's really expected at this point that basically they all had it. And much as with the feathers on dinosaurs, that doesn't rule out a couple of them lost it, or they got rid of it on the head, or they had weird bare feet for some reason, or, reduced on the chest maybe if they superheat like ostriches do. But fundamentally, yeah, all pterosaurs have pycnofibers across the body and wings.
So we don't think they ever turned into anything more advanced than pycnofibers?
No, there's a specimen which we're not sure if it's an asdarchid or not from Brazil, because it's just a leg and an arm. So there's no body, which is frustrating, and there's no head. But that has pycnofibers and that's Cretaceous, and they're still pretty simple and basically just little simple unbranched filaments.
That's really interesting.
Maybe that's what led to their demise.
Well, I think the meteor had something to do with that.
That too.
So I should ask too, since you're a Tyrannosaur guy, what do you think T-Rex had in the way of filament coverage?
Yeah, that's such a hard one. We had Utyrannus, so this 6-7 meter long Tyrannosaur from China, covered, tip of the nose to the tip of the tail to the tip of the toes in simple feathers. I'd seen those specimens. It's 100% genuine. It's completely unambiguous. And from that, plus, of course, all kinds of other feathered dinosaurs, the implication was that basically the Tyrannosaurs were all fully feathered. Then just a couple of years ago, we had this paper by Phil Bell and colleagues going, well, look, here's a bunch of derived tyrannosaurs, and here's a bunch of skin, and there's no real indication that there's feathers here, so maybe they weren't. And a lot of people leapt on this and went, oh my God, no feathers, we're back to scales. And actually, if you read the paper, it doesn't say that. Mm-hmm. They go, we're being cautious here. The obvious implication of the feathers that we've got is that these things probably had them somewhere. Feathers and scales are not mutually exclusive. More recently, that's got a bit more complicated. I know Tom Holtz is working on something on this. I'm not giving anything secret away because he's given a conference talk on this, but he's pointed to some really interesting papers. There's some lovely stuff on elephant skin that's come out. And elephant skin tends to crack and generate these very scale-like shapes and structures entirely off the way that the kind of skin breaks down as it gets really big. Mm-hmm. So it's really quite thick, and then it can crack, and then that ends up looking just like scales, even down virtually to the microscopic level.
Wow.
And of course, there's all kinds of hairs and bits like this sticking between them. And the obvious implication of that, or at least the potential implication for that, is, okay, all these scales with no feathers that have now turned up for tyrannosaurs, how do we know that those things are genuinely the impressions of true reptilian scales and not skin that has cracked to look like a scale? And of course, that's the kind of skin you might expect a large filamented thing to have, because that's kind of what elephants have. And yes, I'm not suggesting that elephants are like reptiles, but elephants, and indeed some of the Asian elephants, can be really quite hairy, and yet they still have these patterns. And of course, unless you have exceptional preservation for your environment, you're not going to preserve the feathers even if they're present. Mm-hmm. So we don't know that those, quote, scales truly are scales. And we don't know that even if they were present, whether or not that would rule out feathers still being there. We don't really still know if feathers are mutually exclusive with scales. If you look at bird feet, for example, they often have little feathers poking out between the scales. Yeah. Now, the scales, inverted commas, on bird feet are actually very heavily modified feathers. Mm-hmm. So you've got this ridiculous complication here. But you've got dinosaurs like Calindrodronius, which appear to show both feathers or both filaments and scales in the same part of the body.
Yeah.
So maybe these things in the tyrannosaurs are just skin, and maybe they are real scales. But even if they are scales, maybe there are still filaments between them or around them, and we're just not picking them up. So you put all of that together and it turns into this massive don't know.
Yeah.
It's a very complicated don't know with all kinds of uncertainties on both sides. And I think you could make a credible case for very scaly Tyrannosaurus and very feathered Tyrannosaurus, or as some weird in between with scales and feathers, or feathers just on the head, or feathers just on the body, or on different patches and of different lengths. But there's no real way of picking between any of those possibilities right now.
Is there any other new research that you have coming up that you'd like to share?
One which I usually try and keep the stuff fairly close to my chest, but this is one that I have been talking publicly about. So with a student of mine and Jordan Mallon and Larry Whitmer, my student, Patrick Hennessy, has been measuring basically every gharial skeleton in the world that we've been able to get our hands on, every skull, I should say.
Wow.
So gharials are these odd group of extant crocodilians with extremely long snouts. But what's neat about them is that the males have this giant growth at the end of the nose.
Mm-hmm.
And that makes them very unusual because they are then basically the only animal, I think, alive now which potentially provides you with a good model for how you might determine males from females based on sexually dimorphic structures.
Mm-hmm.
Because like dinosaurs, they start small and get very big. Like dinosaurs, that takes them many years to achieve that growth. The growth trajectory of the animals as a whole is fairly similar to dinosaurs. They are archosaurs, so they're a relatively close relative, and then they have this dimorphic structure. These males have this feature that the females do not. And that's something you can't say about pretty much any other reptile. So there's strong dimorphism in lots of crocodilians where males are much bigger than females, but they're just bigger versions. They don't necessarily have a feature that the others don't. There are some other reptiles that have this. So male chameleons, a lot of them have horns or bumps and stuff on the head that the females don't. But they take a couple of years to get to adult size. They're not growing over 10, 20 years in a way that we think certainly the big dinosaurs were, and also the gharials will. So these really are, I think, a unique group that you can use for this. But unfortunately, they're extremely endangered. And therefore, there's very few of them in museums generally. And then because the males have these really weird skulls, everyone wants a male. And then wants a big one at that. So actually getting a good data set of lots of different specimens, and in particular small ones, has been very challenging. And we've had to rely somewhat on photographs, of course, for this, but we visited a whole bunch of collections as well. And I think we're now up to something like about 120 specimens,
wow.
Which there was a fairly recent paper actually coming out looking at crocodile growth, and I'm certainly not having a go at this paper, but they were very proud of the fact that they had 25 or 30 specimens for some of their crocodiles and alligators. And you're like, wow. I know some museums that have 30 specimens of alligator mississippiensis. So that's not a huge data set. When we've pulled together 100 plus for the rarest crocodilian, I think we've done a really good job. Now, of course, see if the data and the analyses actually show us anything meaningful at all. But we've at least got a data set to work with.
Nice. Well, thank you so much for coming on our show. And I assume if people want to follow more about you and your work, they should go to your blog, Archosaur Musings, and anywhere else?
Yeah, so I'm on Twitter where I tweet quite a lot, and I fairly recently set up a Facebook page, Dave Holmes Dinosaurs, and so I'm putting a lot of stuff on there because actually it's fairly easy to do in a way. My blog is taking longer and longer and longer for me to get. I just have less and less time, and so writing in-depth pieces. And then Twitter is too tiny to do anything more than 20 words. But Facebook is this nice compromise where I can easily shove up half a dozen photos and write 5 lines. So that's probably my primary one at the moment. But if you can find any of them, they're all kind of cross-linked. So and I use them for different things as well, because I think you can reach different audiences because those formats are different. So if you really like my stuff, you should follow all of them.
Nice.
Definitely. I'm on the Facebook page right now. I see you've got a Tyrannosaur and a pterosaur and the
Yeah, so
logo.
the little logo.
Mm-hmm.
David Orr did that for me. He designed that little logo under my direction.
Nice.
And they're supposed to be Duchang tyrannus and Bella Brunus. So two of the first things that I named. So that's a Tyrannosaur I named and a Pterosaur I named. So that's kind of my logo.
Awesome.
Yeah,
It's a good logo.
it is. Fits in perfectly with what we talked about today, too.
Yeah.
Yeah. Well, yeah, and that was kind of it. So.
Great. Well, thank you so much for chatting with us.
Thanks very much. Good to speak to you again.
Thanks again, Dave. That was really fascinating. Interesting enough to get us to branch out a little bit from our normal dinosaur conversation. But how could we pass up on such an amazing new pterosaur? It was just so cool. And before we get into our dinosaur of the day, just a quick reminder that we have a Patreon. If you listened to that interview and you thought, I want to hear more, there is a significantly longer version available for our patrons. So if you are a patron, then make sure you check out your custom RSS feed. It should be immediately before this episode, so you might have already listened to it. And if you're not a patron, please consider signing up. You can do that at patreon.com/iknowdino. And if you sign up, you'll also get other rewards like joining our Discord server, seeing all of our hidden posts, which include videos from our trip to Japan, where we went to some different museums and lots of other stuff. And you can also request a dinosaur of the day. And at other levels, you can also get copies of our books or the show ad-free or get a shout out, all sorts of good stuff. So head over to patreon.com/iknowdino and see which level you might want to join at.
And now on to our dinosaur of the day, Skorpiovenator, which was a request from Velociraptor256 via Discord and Patreon. Speaking of perks of being one of our patrons, as Garrett mentioned, if you join, then you get to request dinosaurs. Skorpiovenator was an Abelisaurid that lived in the Late Cretaceous in what is now Argentina, in the Huincul Formation. It was one of the most complete Abelisaurids known, and the holotype was mostly complete. It was only missing parts of the tail and forelimbs. Skorpiovenator was estimated to be 19.7 feet or 6 meters long. Gregory Paul estimated it to be 24.6 feet or 7.5 meters long, though, and weigh 1.67 tons. Another estimate in 2016 said that it was 20.3 feet or 6.2 meters long. Skorpiovenator had short, pretty much useless arms.
Being an Abelisaurid, that's not too surprising.
Yes, but it did have strong legs and thighs. It had a short, stout skull that had many ridges, furrows, and bumps. It's not clear why it had so many bumps on its head. Its skull was shorter and deeper than Abelisaurus and Majungasaurus. Skorpiovenator had 19 maxillary teeth, which is more than other Abelisaurids. Since so many teeth were found with the skeleton, the discovery of Skorpiovenator makes it easier for scientists to compare teeth and figure out what kind of dinosaur it came from. So it's possible that teeth thought to be from carcharodontosaurids at the end of the Cretaceous may have been Skorpiovenator or other Abelisaurids, and this helps shed more light on the types of dinosaurs that lived in the Cretaceous in South America. Skorpiovenator was described in 2009 by Canale, Scanferia, Agnolan, and Novas, and the name means scorpion hunter, and that's because there were a lot of scorpions at the dig site.
It's a really cool name.
Mm-hmm.
The origin of the name is less cool than thinking of it as a giant scorpion-like dinosaur, though.
True.
At first, I was kind of expecting it to be a stegosaur, because you could imagine an analogy there with the big spiky tail to a scorpion.
Mm-hmm.
But being a remarkably complete Abelisaurus, I'm surprised Skorpiovenator isn't in more pop culture. It's such a cool sounding dinosaur.
Maybe it'll pop up in the next Jurassic World.
Maybe.
The full type species name is Skorpiovenator boustingorii, and the species name is in honor of Manuel Boustingori, owner of the farm where the dinosaur was found. Other dinosaurs that lived in the same time and place included Carcharodontosaurid Mapusaurus and the Abelisaurid Elocalesia. The Skorpiovenator fossils are now at the Ernesto Bachmann Paleontological Museum of Villa El Chocón in Patagonia, Argentina.
Not sure if they're on display, though.
Yes.
And our fun fact of the day is that it's probable that pterosaurs and early flying dinosaurs were regularly eating each other.
Because why not?
I really do think that it's likely that these two were interacting a lot, because basically everything that flies now, every category of things that fly, are eating each other. They're constantly battling it out. And we know that birds eat each other today Dave Hone mentioned the peregrine falcon eating a pigeon, and I found a really fun article by the Scottish Sun that was titled "Raptor Attack. Peregrine falcon fights off crows to snatch pigeon in Aberdeen city centre, leaving blood everywhere."
Yikes.
It's pretty funny. It shows a picture of the peregrine falcon flying with like a partly eaten pigeon. So yeah, you can imagine. There's also hawks, which are apparently notorious for hunting other birds, sometimes at bird baths or bird feeders.
But you go where the prey is.
Exactly. So that people put out like a bird feeder thinking like, oh, I'll be able to see this bird. And then a hawk comes in and eats the bird that they're trying to attract. It's pretty crazy. There's also the cute little northern shrike, which is also known as the butcher bird. It's very small. It is objectively a very cute bird. It's called the butcher bird, though, because it likes to impale its prey on barbed wire, thorns, or anything else sharp it can find.
That's not cute.
No. They hunt insects, lizards, mice, but they've also been known to go after other small birds like starlings and sparrows, which are pretty much the same size as this bird, but they just impale them or do whatever they can to get them. And then gulls are probably the best adapted at eating fish, but they can also take down ducks, pigeons, puffins, and other gulls.
Ooh.
Yeah, so among these three categories, they're all very different hunting styles. So the raptors obviously hunt with their talons, which is kind of what we think about when we compare them to dromaeosaurs, hunting with those big talons. But then the butcher bird is something that you'd never imagine. Like you just find something sharp and shove your prey onto it. It's insane. But I'm sure there were sharp things back in the Cretaceous, or, maybe they could fly up with it and drop it like we see crows and stuff do with
The crack nuts.
Yeah, or open mollusks. But gulls have an entirely different strategy, which seems like it's straight out of a dragon fighting movie or something, because what they do, since they don't have claws or a sharp curved beak, their preferred hunting method is to fly all around their prey and either exhaust it or open wounds by jabbing it with their beaks and then kind of waiting for them to bleed out and then eating them, which you could imagine a pterosaur doing. I think it's a perfect analogy because their beak isn't really great for tearing open midair. A lot of them probably didn't have the talons necessary, but with that big pointy beak, you could imagine them pecking holes and things.
This is why you can't trust birds.
No, you can't trust any nature. It's not your friend. But I think some of these methods could be really used well in paleo art. If you imagine some of these different attack styles between flying dinosaurs and pterosaurs.
And on that lovely note, that wraps up this episode of I Know Dino. Thanks for listening. Don't forget to subscribe so you don't miss out on any new episodes. And consider joining our community, patreon.com/iknowdino. Thanks again, and until next time.